Welcome to your lesson. I am Darth Vader, and today I am your teacher. We are going to be covering trigonometric ratios and functions, located in 9.9 and 9.10 in your books. Let's get started. Your objectives for today: you will understand 3 basic trigonometric relationships, and you will use trigonometric ratios to solve right triangles.
And that's enough of that. Let's start with the basics, shall we? First, since we're dealing with right triangles, let's get one of those on here. Triangle ABC. Next, we start with the 3 trig functions that we're going to use. Okay, now these are all going to be in relation to angle A, because if you did it with a different angle, you would get a different ratio. I'll explain that in a minute. First, let's start with sine. So the sine of angle A, which when we say angle A, we're talking about the measure of angle A, but for the purpose of introducing it, we're just going to call it angle A. Okay, that's the opposite leg, which is CB, over the hypotenuse, which is AC. Cosine of A is the adjacent leg, so the leg that makes up one of the angles, which is AB, over the hypotenuse, which again is AC. And finally, we have the tangent of angle A, which is the opposite leg, in this case CB, over the adjacent leg, which is AB in this particular case. Now that's all well and good. The problem is, how do you remember which one's which? Well, there happens to be a mnemonic device to help you do this. Some of you may have heard this. Okay, let's start with sine. Sine equals opposite over hypotenuse, so we say so. Cosine is adjacent over hypotenuse, so we say ka. And tangent is opposite over adjacent, so we say toa. Put them together, and you get SOHCAHTOA. Now there's a few different stories that can help you remember the fact that there is an Indian prince or princess, depending on the story that you read, named SOHCAHTOA, etc., etc. But I don't want to waste 5 minutes here reading a story to you that you can find online. So let's just get into it. Okay, say we have triangle ABC, and we know that leg BC is 3 and hypotenuse BA is 5. And we don't know AC. But we need to find the 3 trigonometric ratios of angle A and angle B. First, we need to figure out what x is. So we could use the Pythagorean theorem if we want, or we could just see that this happens to be a Pythagorean triple. And that's going to give us that x equals 4. Okay, now that we have all 3 sides, just need to remember that sine, cosine, and tangent are all determined by the angle we're trying to find. So, in this case, if we have angle A, okay, that's going to be, let's start with sine. Sine is opposite, which is 3, over hypotenuse, which is 5. So we get 3 over 5. If we do cosine, we have adjacent, which we said x equals 4, right? Over hypotenuse, which is 5. And finally, tangent would be opposite, which is 3, over adjacent, which is 4. So we could write that as such. Sine of angle A equals 3 over 5. Cosine of angle A equals 4 over 5. And the tangent of angle A equals 3 over 4. Now let's see how that changes when we're looking at angle B. So now you can see that they're different. Even though we're talking about the same triangle, these ratios are different, because for angle B, the opposite is 4. The hypotenuse is still 5. That doesn't change. Cosine, that's adjacent, which in this case is now 3 over 5. And the tangent, it's opposite over adjacent, so 4 over 3 as opposed to 3 over 4. So that kind of illustrates that it really is going to change depending on which angle you're talking about. So just keep that in the back of your mind. Be very, very careful of that. All right, so now when we have those trigonometric ratios down, you're going to be presented with quite a few word problems. So for some applications of trigonometry, you need to know the meanings of angle of elevation and angle of depression. So let's say we have an observer at point P, and he looks up toward an object, let's say a flag, okay, at A. The angle, the line of sight, PA, so that's where they're looking from and to, makes with the horizontal, and it's always going to be a straight horizontal, okay, is called the angle of elevation. This in here. Now, the angle of elevation is easy. It's hard to get confused on that one. What's not hard to get confused on, and you need to be careful of, is angle of depression. So, let's say that we have an observer at point P looking down towards an object at B. The angle of the line of sight PB makes with the horizontal, which is PH, is called the angle of depression. Okay. Now notice that the angle of depression always goes from the horizontal to the line of sight. Okay, it is not in here. So don't use the vertical, as my note here says. Remember that the angle of depression is an angle between the line of sight, okay, and the horizontal, not the vertical. Easy enough. All right, so let's try a practice problem. We need to find the altitude of the isosceles trapezoid ABCD. So we've got our altitude drawn in here, ED. So remember, it creates a 90-degree angle. All right. And what do we know about an isosceles trapezoid? Well, we know that the legs are congruent. They have the same measure. So if that side is 25, then this side must also be 25. Now we can use trig functions to find out the measure of that altitude. What's going to happen is we're going to say that the sine, because we don't know the opposite, and that's what we're trying to find. Remember, sine is opposite over hypotenuse. So we're trying to find this. So the sine of the measure of angle A, which in this case we do know is 38 degrees, is ED, your opposite, over your hypotenuse, which is 25. Now, just like with any type of algebra problem, this is what we're trying to find, so we need to get that by itself. So we can say, well, we're going to multiply both sides by 25, which would eliminate the 25 here, and give us 25 times the sine of 38 degrees equals ED. Now, there is a table in your book that can tell you the different trig functions for different angle measures. Or there's a button on your calculator that does the same thing. You would simply hit sine 38 and enter, and you would get 0.6157. That's rounded. You'd actually get a longer decimal place number. So we can take 25 and multiply it by that. And since we don't want some big long number, we're going to estimate and round to the nearest tenth. In this case, we're going to say that ED is about 15.4. Okay. Now, if your problem asks you to round to the nearest hundredth, then do so. But if it doesn't mention anything, round to the nearest tenth. All right, now let's try an actual word problem where we're working with either angle of elevation or angle of depression. Since we're doing a Star Wars themed video, let's do a Death Star problem. Now, if you've seen the movie, this will be familiar. If not, then just go with it. So Luke must hit a small target on the Death Star by flying a horizontal distance to the target of 366.26 kilometers. When the target is sighted, the onboard computer calculates the angle of depression to be 28 degrees. Now, if he hasn't fired yet and he flies another 150 kilometers, the target, which has not yet been passed, has an angle of depression of 42 degrees. How far is the target from Luke's X-Wing fighter at that instant? So here we have our X-Wing fighter, and your target is right down here. This angle of depression is 42 degrees, and he's going to fly this entire distance, which is from here to here, from the X-Wing fighter to here, right above the target, is 366.26 kilometers. All right, so let's give ourselves a little bit more room. All right, so he's flown about 150 kilometers. And if the total distance is 366.26 kilometers, then that leaves a distance here of 216.26. Now, we do know that the new angle of depression is 42 degrees. Okay, this one they told you was 28. In this particular problem that we're doing, it doesn't affect the problem at all. It's more of a distractor. So if we dropped down and created a right angle, we would know that this is a right triangle. So now we can use a trig function to figure this out. Question is, which one do we use? Well, we've got our angle. We're not trying to find this right here. Okay, what we need is this, the hypotenuse, and we have the adjacent. So in that case, we use cosine. Okay? So we know the cosine of the angle 42 degrees equals, now remember, cosine is adjacent over hypotenuse. So 216.26 over, we're just going to call it x. And we want to solve for x. So what we do is we could multiply both sides by x and divide both sides by the cosine of 42. Because what that's going to do is make them switch places. Those will cancel out. These will cancel out. And it'll leave you with x equals 216.26 over the cosine of 42. And if you go ahead and you plug that into your calculator, you'll end up with the answer 291 kilometers, about. There we go. So your answer would be the distance from his X-Wing fighter to the target is 291 kilometers. And if he made that shot right at that moment and set all of his calculations correctly, it would result in this. Yeah, isn't that pretty? So anyway, that's an example of how a trig function could be used in a word problem. And hope you enjoyed the video.